So now let's talk about class methods. Class methods are slightly different from static methods in that, like instances methods, they also take a special first argument, but in this case, it's the class object itself. A very common use case for coding class methods is to provide factory capability to the class. Let's see an example. Let's create a new file called class methods factory, okay? So class dot methods dot factory, okay? Dot py, of course. Let's create a new class called point. Def init, you can say self dot x equal to x, self dot y equal to y, self comma x and y. Let's remove this. Class methods def from tuple cls comma quotes return cls quotes. Another class method def from point cls point return cls location point dot x point dot y. Of course, here cls is point, and also cls here is point. Okay, so let's execute with a simple example. I'm gonna say p equals point dot from tuple 3 7 print px comma py. Okay, and it's very simple. Let's run a terminal, new terminal. Well, I created many terminals here. File p and class methods factory. Okay, we've got 3 and 4 and 7. Okay, which are from this attribute. It's from point here. Let's continue with this exercise. You can say q equal to point dot from point. I wanna pass p. I wanna print q dot x and q dot y. Let's execute it again, and you've got the same result. Really interesting, right? So let's continue with another subject. Let's check private methods and name making. Okay, if you have any background with languages like Java, C# or C++, then you know them. No, they allow the programmer to assign privacy status to attributes, both data and methods. Each language has its own slightly different flavor for this, but the key is that public attributes are accessible from any point in the code, while private ones are accessible only within the scope they are defined in. Okay? In Python, there is no such thing. Everything is public, and therefore we rely on conventions and on mechanisms called name mangling. The convention is as follows. If an attribute's name has no leading underscore, it's considered public. This means you can access it or modify it freely. Then, when the name has one leading underscore, the attribute is considered private, which means it's probably meant to be used internally, and you should not use it or modify it from the outside. Let's try with an example, right? So let's create a new file called private attributes.py in OP folder. Let's define a class called A def init, okay, self.factor equal to factor. Factor of course comes from these parameters. Now let's define op1 self print op1 with factor dot format self factor. Let's check here is self home, okay. Class A is done, so let's define our class B. We're here for an A. The op2 we would receive a self attribute parameters and also factor. Let's set self dot factor equal to factor and also print a message op2 with factor dot format self dot factor, okay, it's underscore factor. Now let's move this terminal from here. You can say now object is equal to b 100 obj dot op1 op2 with 42 as a parameter, and now obj op1. Let's execute it and see what's happening here. Okay, private method, private attribute, and we've got an error here. Let's see what is missing. Did you mean factor? Where? Oh, card is factor here. Okay. Now actually our factor and factor, okay. Let's clear it and let's execute again. opt1 with a factor of 100. Okay, this is right. opt1. opt2 with a factor of 42. Okay, it's okay. The last one is wrong, right? opt1 with a factor of 42. You know for what? Factor was prepared for 42 value, so in the next execution opt1 is printing 42, but we're expecting another behavior. In the preceding code we have an attribute called factor, okay, and let's pretend it's so important that it isn't modified at runtime after the instance is created, because opt1 depends on it to the function currently. We've named it with a leading underscore, but the issue here is that when we call object.opt242, we modify it and it's reflected in a subsequent call to opt1. Okay? So let's fix it again. Just by doing this, let's add another underscore here. Okay. Here also. Here also. Let's execute it again. Let's create it. And we'll see the magic. And now I wanna show you something. Let's print the object dot let's go underscore text dot keys. Okay, I will see something interesting here. You'll see that we've got a factor for A class and factor for B class. Okay, that's the reason we are not overwriting the value, because if we remove this, okay, I'm sorry, with a single underscore, what we got here is just factor. That's the reason. One single attribute for both classes, it will replace it. Okay, so let's go back, and now it's right.